I'm Spyros Yannopoulos. I'm professor at the Department of Chemistry in the University of Patras, and I'm research director at the Foundation for Research and Technology Hellas 4th, at which I was a researcher for 25 years before I moved to the university. And actually, I'm the coordinator of GRAPHERGIA. GRAPHERGIA is a project which has two directions. One direction is related to the smart textiles and how textiles can harvest our biomechanical energy as we are moving, how this energy can be stored to some in-plane textile-based supercapacitors, and this energy can be used to power some low-power consuming devices and act as, let's say, a network connecting us with the Internet of Things. The other direction is related to the development of a dry process, radically different from what is used up to now in the industry. And this technology is based on the laser-assisted, let's say, graphene production of electrodes directly on graphene, on battery electrodes, especially in the field of lithium-ion batteries. During the first year, our team at Ford was charged with the development of the foundations of the process. We have tested different precursor materials, including well-known graphene oxide, for example, material which is studied in detail in the previous graphene flagship phase. Also other low-cost polymers or even biomass-derived products, which are very low-cost products. The idea is how to transform them using industrial-type laser sources to graphene-like or graphene-related materials, which can be either doped with heteroatoms, which give additional properties, or decorated with nanoparticles. So in the first year, beyond, let's say, the setting down the foundations of the technology, we have tested and developed several textile-based supercapacitors and electrodes for lithium-ion batteries, in collaboration, of course, with several of the project partners. During the second year, we are going to continue the optimization of the process we achieved in the first year, but at the same time, new tasks will start, especially tasks related to the deposition of energy harvesting layers, some polymer-type materials, which will be deposited onto graphene. And in this way, we're going to create this energy harvesting flexible triboelectric nanogenerators. In this sense, we have to optimize the process of the energy harvesting layer deposition and also collaborate with other teams, like the team of the University of Gustave Eiffel, Philippe Basset, who are going, let's say, to prepare the conditioning circuits and couple these devices with supercapacitors. At the same time, we'll collaborate with other teams to study aging effects in lithium-ion batteries. This means how the materials degrade after several cycles of operation using some ultra-fast spectroscopic techniques. We have established some first steps of collaboration with the project ARMS, which is the sister project in graphene flagship related to GRAPHERGIA, as they are working also on energy storage using supercapacitors. So together with ARMS, we have collaborated, actually participated in a conference in Tampere this summer in Finland about flexible electronics, where we discussed common aspects of our projects. Also, we co-organized in this event, Graphene Week, a common workshop, and we have been in close contact with them for exchanging knowledge, exchanging samples, and trying to find common routes for graphene-related materials. The impact of GRAPHERGIA on our society can be multiple, depending on the application sector of GRAPHERGIA. One of the directions of GRAPHERGIA is related to lithium-ion batteries. So it's easy to realize that if you manage to advance a method that is capable of producing in a less costly way and more environmentally friendly manner. The production of electrodes for lithium-ion batteries, this can have a high impact in the future for different applications in stationary and mobility. So from the point of view of smart textiles, the impact can be also important because you can imagine that our textile can be in the future an interface between the human and the environment. So in the case we are able to have a self-charging textile just achieved by the biomechanical motion of a person, this can offer possibilities of remote connectivity of people who, let's say, are run out of batteries, for example, in remote areas. They can generate energy from their textile just to provide the signal. On the other hand, creating new processes in collaboration with companies like Adamant Composites and Pleione Energy, we expect that in the future more jobs can be created for our society for the new products anticipated by GRAPHERGIA. Graphene and 2D materials have been under very strong, let's say, focus over the last 20 years. The scientific merit of these materials is rather well known. What is still not completely achieved is a high portfolio of applications. So we expect that with methods like the one we propose in GRAPHERGIA for producing high-quality graphene at a low cost and with an environmentally friendly way, we expect that graphene electrodes for different applications may, let's say, boost the future of energy storage. This is something to be seen. We are still in the first year of GRAPHERGIA. We hope that at the end we will be at the proper TRL level to have some real-world application with laser-grown graphene.